So we should be able to somehow apply also economic research results to the whole field of economy or to the big economic models that we would like to have in place. Right? So essentially this means that we just add more variables, endogenize them to a big economic model, to a more realistic model. And just an example, last time Camino with a nice production function, I mean, they worked a lot and came out with a nice function which links production from agriculture, from rice to climate. And in my example, I need to have that climate economics connection to be able to predict global warming and its effects on the society and all that. So I really need her function to put it in my model to make my model more realistic. So this is an incremental approach to research. I need what she did. Also, I mean, like this work, I mean, you're going to see an example that we do for 1,000. He connects financial market participation to level of wealth of the people in the market. So that's also useful. I mean, if I want to add to my macroeconomic model financial markets, I should apply them because it's valid research, right? I mean, we work on it, supposedly it's good, valuable, usable, so I should be able to use them. So now, just to end the introduction part, I mean the part where I try to build a case for what we do. So I think, I mean, in general, and I mean, here I invite you to make comments. The way to build a big and realistic and useful economic model is to define the economic variables as a state of the economic model, and then they use these research results to connect them and make sure that when they are all together, they still produce an outcome that you would expect from the economy that you're building. And while doing that, make sure that future research still comes in and uses, I mean, can be applied readily to what has been done. So this is really just my personal idea. I hope that the things that I've stated here should be accurate in terms of economics. If they're not, there's a disclaimer that the ideas presented are solely mine, not of my employer, unless they are good ideas. In that case, they are of my employer.
So your first point is to say that you should sort of modularize economic models?
Yes.
Break everything up into different communicating things?
Yes. So that we can add more and more pieces and make the whole more realistic. Of course, that's going to be a mess, but that's why we're here to work on it. So, just in general, how such an dynamic economic model would look like, I mean, it has to deal with all these changes. There are structural changes. There are new variables. Some new institutions came to the market. Some new markets are set up. I don't know, the CBS. Maybe it didn't exist 10 years ago. Or some new research uncovers some relation between some variables in the market. I should be able to add those changes. Or some actors change their functions, their utility functions. I don't know, we all become tree huggers and go green and all that. I should be able to place that in the model and have the model speak out the right state of the economy, the right place of the economy, and still solve. So essentially, this is the big general idea that I'm kind of shooting for. Now, getting down to earth, you can see from this, and you can see from the other points that I made, that it seems like there's a lot of work to automate, a lot of research to make sure that pieces are connected together and that they work together, and all this need for automation and for a system that has a platform for economic research needs a lot of work from people not really researchers, are not economic researchers, but are researchers in systems and computer science and all that aspects. So this is more like a proposal of me that I'm trying to build this. If you think it's useful, or if you think it's not useful, just tell me, and so that I can adjust for your needs or for your advices. So now, like I said, down to earth. This is the part where I actually tell you what we really do in detail. So this is the more applied computational part. So what do we use? Like I mentioned, we're dealing with these economists, and the main person is Robert Townsend, who moved to MIT. There's also on the side, I'm dealing with Ken Judd, who from time to time every forequarter comes here and teaches computational economics classes, and there are others like people from Harvard who do applied economics. So I deal with all these people and I have to solve some of their problems, and I'm just going to go through what I see with their problems and how I'm solving them. So pretty much, this is the pretty general statement, and it's my observation that economy pretty much boils down to some optimization. You already know that. And that's a good thing because there are so many optimization functions and algorithms and everything available that you can readily make use of. But these models that you work with and what we model are pretty much, in many cases, non-linear. So that kind of breaks the nice methods, optimization methods, and forces us to do numerical simulations. So we're also somewhat doing numerical methods. So also, last but not least, which is actually this should be the most important one from my perspective, this is what I really offer. We offer these high-performance parallel platforms for you to use for the execution of your models. So I'm gonna go, like I think the next time I'm gonna actually go into details about this. But essentially what we do, with respect to these things, we look at some research, we divide it into blocks. We treat optimization especially because it's something that we can't really touch too much. And then in general try to rearrange the application such that it's usable in the future. All these, this what I just described here, this part is Victor's part. He does everything. He takes the models, breaks them apart, rearranges them, reassembles them, gives them to me. And then I come by and I use this tool which allows me to run the reorganized, reassembled models in parallel on lots of computational resources.